All right, welcome everyone. So this is a lecture on 4.7, first lecture. I think there'll be a couple. 4.7 is inverse trigonometric functions, and initially I'll give you an overview what inverse functions are. Then we'll look at graphs of trigonometric inverses, and then we'll be just solving problems, evaluating inverse trigonometric functions. Alright, so let's start with the definition. It's not really a precise definition, but it's inverse function. It'll suffice. Alright, so inverse function reverses the action of the original. Okay, so basically what it means, I'll give you an example, but for now, let's just look at, alright, so I have a function, and that's my input, right, x, and this is my output. And now when I look at the inverse function will take that output, right, that y, and will give me back my input, my x. Alright, so let's look at an example. So f of x, take something simple, 2x minus 1. So what I'll do, I'll evaluate that for 2, f of 2. So I'm gonna get 2 times 2 minus 1, and that will give me 4 minus 1, 3. Okay, so my g, right? My g will take that 3. Right, so you see I'm taking that 3 and putting it in place of x. And I'll have some formula. I hope you guys can figure out what that formula is. And it's gonna give me 2. Alright, so you can pause the video, figure out the formula. Alright, so basically when you're thinking about that formula, right, that you need to use the same numbers, right? Same numbers will go here. Right, and also the variable. So pause the video, try to figure it out. Alright, I hope you've done that. So, well, last things first, so and reversed, right? So I'm subtracting 1, so I'm adding 1. I did it last, I'm doing it first. Then I multiply by 2, I'm going to divide by 2. Okay, so that's my formula. And now I like you to look at what happened, right? So this was my y, right? This was my x in my original function. But in this function, right, this is, how should I do it? Maybe like this. Yeah, this is my x, and this is my y. Okay, so what happened, you see that y's became x's and x's became y's. Okay, so we're gonna use that property of inverse function. So let's just make a little note, switch x's and y's. Right, so that's basically what the inverse function does. Alright, so let's look at the graph of some interesting function. So y equals logarithm base 2 of x. So just to remind you, right, so that this is asking me, well, maybe I'll give you an example. So y equals log base 2 of 8. Right, so this is asking me what power do I put here to give me 8? Right? So that power is the solution, right, of this problem. So it would be 3, right? But you guys can see that if I want to graph it, right, it'd be quite difficult to select my x's and then calculate my y's. So what I'll do, I'll graph first the inverse of that. The inverse of that is an exponential function. Okay, well, I'm just going to make a table with a couple of values, x, y, so -2, -1, 0, 1, and 2. Okay, and calculate my y. So 2 to the -2 is 1/4. Here 1/2. 2 to the 0 power is 1, right? Just like any other number with 0 power. 2 to the first power is 2, and 2 to the second power is 4. Okay, so now, right, I don't really need to calculate anything here, right, for this logarithmic function. I just need to, right, since they are inverses, I just need to switch x's and y's, right, and that's what I'll do. So x's become y's, 0, 1, and 2, and y's become x's. Okay, so this column goes here. I just need to copy the numbers, so 1/4, half, 1, 2, and 4. Okay, so now we can graph. Let's graph both, right, so that we know what's going on. So I need to go to 4. Let's just go like this. Yeah, I'm just gonna do it quickly, but you guys can pause the video and plot the points, right, for yourself. Okay. So maybe let's make this one blue and the other one green. So this one will be green. Okay. So for -2 I have 1/4. For 1 I have half. For 0 I have 1. For 1 I have 2. For 2 I have 4. Okay, so this is my exponential. Okay, it keeps going up. So this is my y equals 2 to the x. Alright, let's do the other one. What did I say? Green, right? So here I have for 1/4 I have -2, so I'm here. Then for half I have -1, so here. For 1 is 0. For 2 is 1. And for 4 I should be at 2. Alright. Okay, so you see that it creates this nice symmetrical graph, well, two graphs. And if you look at it closely, right, you can see that this is the line of symmetry, right? So I can plot the... I didn't even have to do this, right, to graph that. I could have graphed this and then reflected all the points, right, across that line. On that line, the equation is y equals x. And this one is y equals logarithm base 2 of x. Okay. So that's a little bit of an introduction to just to show you what's going on with those inverse functions, how they work. Let's look at the first one. So first thing we're going to do is sine, the graph of sine. Alright, so we're going to do it in a similar way to this. Let's see. It's kind of cool. At least I think it's cool. Alright. So, okay, sine function. Okay, so let's just look at the notation. So this is my regular, right? This is the original function f of x equals sine x. So the notation will look like this. So y equals sine, and then we put -1 in the exponent of x, or y equals arc sine of x. Okay, when you might be confused by this, right? So this -1 just means inverse, right? It does not mean, so let me just write it like this. So sine -1 x, it does not mean 1 over sine of x, right? Keep that in mind, right? Alright, let's look at that graph. Yeah, let's take a lighter pen. Okay. Let me make it's kind of dark here. A little more light. Shed a little more light on those things. Now, so this is my x-axis, and so I'll just graph the way I'll do it. I'll graph regular y equals sine x, right, and then I'll switch the coordinates. You'll see. So +1, so this is 1, this is -1, this will be pi over 2, pi, what is that, 3 pi over 2, this would be negative pi over 2, what is that, negative pi, negative 3 pi over 2. Okay, so I'm graphing regular sine, right? So it goes through the origin, then 1 here, and -1 here, and here I go to -1, and then to 0, and then for this I'm back at 1. So I'll connect the points with a smooth curve. Alright. Next thing I will do, I'll well, basically switch x's and y's, right? Let me look at a nice green pen. Alright, so this is how I'll do it, right? So this, the pi's, right, the angles will be on the y-axis, right? And this -1 and 1 will be on the x-axis, right? And so this is the positive, right? So positive x-axis, so this is going to be +1, not -1. Okay, so this is the negative side, so it's going to be -1 here. Okay, and then I'll have, maybe I'll actually, because when I was originally doing it, I was doing it like this. Okay, so now, so this is pi over 2, so pi over 2 will be here. So negative pi over 2 will be here. And then this will be pi, and this will be negative pi. Negative pi over 2. Okay, so now we're just going to graph it, right? So I know I need to go through 0, and then for pi over 2 I have 1, right? And then for pi I have 0, then I'm going down to -1 and up to 0. Okay, I connect the dots, points, and I get a graph of inverse of sine. Okay, so let's label the graphs. So this one is, let's call it arc sine of x. Okay, the other one is just y equals sine of x. Okay, so now, you know, when I'm thinking mathematically, right, I like to see and think about functions. Unfortunately, when you look at the green line, right, the graph of inverse of sine, and you start doing your vertical line test, right, you'll see that this is not actually a function, right? And the problem is that for some x's, like for, I don't know what this could be, 0.5, right, I would get infinite number of different y's, right, and this is not acceptable. This is not a function. So what I need to do, I need to cut it, right, or they say restrict, right, restrict domain. But for now, let's think of it as cutting, right? So if I cut my function here, right, and throw away this part, and then I cut my function over here, and you guys see those beautiful scissors, and throw away this part, right, I'll have a graph of something that will be a function, right? So I'll have just this piece. Okay. So what actually happened was we also cut this one, right, over here and over there, right? So we cut in we restricted domain of that, of the original, and then well, we did an inverse, made an inverse of it, right, to get the green shape, to get inverse of sine. Okay, let me just quickly redraw it, right? Redraw just the function without all this other stuff. Okay, so the original was like this. So this was pi over 2. This was 1. This was negative 1. And this was negative pi over 2. I don't think I need any more of that. So the original one looked like this, right? So these are my points. Okay. So that was my sine. And then this became pi over 2. This was still 0, negative pi over 2. This is my 1, and this is negative 1. Okay, so now for pi over 2 I have 1, or for 1 I have pi over 2, right? We need to think, and then in terms of inverses, and then for negative pi over 2 I have negative 1. Okay, so the graph look like this, right? So you got this and then like that. So you guys see how, and it's symmetrical with respect to that line. Oh boy, you guys couldn't see anything. Anyway, now you can see. Okay, so now let's think about, so the green one is the inverse, right? So this is my sine, inverse of sine. Okay, let's think about domain. This will become quite important. Alright, domain of the green one, right? So I go look at the x's. So it goes from negative 1 to 1, inclusive, meaning negative 1 and 1 are part of the domain. And range is from negative pi over 2 to pi over 2. Okay. Alright, it's been about 20 minutes, well exactly 20 minutes, so I'll stop here. And next thing we'll do, we'll do a couple of problems just to show you what type of problems we'll be dealing with. Okay.